Welcome student to part 2 of L'Hopital rule section 4.4. Today we will continue talking about the indeterminate forms, and today we have a special type of indeterminate form which could be 1 to the power of infinity, infinity to the power of 0, and 0 to the power of infinity. Now some of those might be familiar because if we take number 1 and we take it to any power, the answer is always 7. Now, if we increase 7 to 800, the answer was still 1. Sorry, this should be 1 here. And so on. And what we have learned in school, 1 to the n is 1. Now, the answer is always 1, except if the power goes to infinity. Here we have to be very careful, because we call it indeterminate form. Similarly, 0 to any power should be 0, except when we have the infinity, then there is something else that could happen here. Also, we have 0 to the power of 0. We have to be a little bit careful with that. So infinity, 0 and 1, if we mix them together, we get indeterminate form. Now, what is the idea if we have this situation? The idea if we have this situation is we try to take the power to go in the denominator. Somehow we have to find a clever way to make the power in the denominator. And why I would do this? Because the target I have in mind is to use L'Hopital rule. And in order to use L'Hopital rule, I should have numerator and denominator. Something in the top, something in the bottom, and then I use L'Hopital rule. So what is the magic idea in determinant form if we have the power is as follows. So let me solve this question, and while I'm solving it, I'll explain to you what should be done. So here is, we take my limit, and the first step, as usual, I will do a direct substitution. Let me do direct substitution somewhere here in the border. If we substitute 1, we get 1 to the power of 1 over, since I'm doing 1 plus, this will be 0 plus, which is 1 to the power of infinity. Okay, kind of substitution, and this is indeterminate form, so we have to do something about it. We cannot keep it as it is. We have to find something. And the idea is, the first step, I don't know the answer, so I will call it L. Just a number, maybe 7, 10, 11, 0, 1, just call it L. Okay. Now what will be the next step? The next step, I will write everything as it is, but I will take the len of both sides. So I will use len, and I will use len. That's the second step. The third step, the len and the limit, I will switch them. I can switch them as long as this limit exists. We will switch them. The function is continuous. You can take the len here inside. So let me do this. On the left side, we still have len L. In the right side, we have the limit as x goes to 1 plus. And then we have len of x to 1 over x negative 1. Now, if you remember, if we have len and then we have a power, what will happen to the power? The power will go down in front of the len. That's the idea of having the len. The len will give me the power down on the line. So just imagine how powerful the len is taking the power down in the line. So we have len L equal, we keep the limit, still I didn't use L'Hopital yet. Now if you take the power is this one, and then you have len x. Now I think this one I can rewrite it as this, because x minus 1 is in the denominator. I can just write it in the denominator, x negative 1. In the numerator, you have ln x and 1, so what is left for you is ln x. I think now this seems to be a perfect situation to use L'Hopital rule, but before I use L'Hopital rule, let me do direct substitution. If we substitute 1, we get ln 1 plus over 1 plus minus 1, and this is ln 1 is 0, 1 minus 1 is 0, so perfect, I can use L'Hopital. In order to use L'Hopital, as usual, we need to take the derivative of the numerator, which is 1 over x, derivative of the denominator, which is 1. And then we do direct substitution, and if we do direct substitution, what we get is, if you substitute 1, it could 1 over 1 over 1, the answer would be 1. So the answer is 1. Okay. Now, if you have ln L equal to 1, how do you find only L? We need to cancel the ln. And what will cancel the ln is, if you remember from calculus 1, is taking everything to the power of e. So what I will do, I will write e to the power of ln L equal e to the power of 1. Now, this ln and e, they will cancel each other, and you will left up with your L, and that's the final answer is L equal to e power 1, and usually we don't write e power 1, we just write it as e, and the answer is e. So you can go through this one and check your solution. Okay. Now let me go to a similar question of similar type, which is this one. Now in this question, we need to substitute infinity the first step, and if you substitute infinity, if you put here infinity and here infinity, the power will be infinity, and this will be 1 over infinity is 0. So we get 1 to the infinity. Again, this is indeterminate form. Now, since we have the power and we want to take the power down on the line, what we need to do, what's next to be done, is to use the same idea of having L. So I will take this limit to be L, and then I will use the ln. Okay, so the next one, I would just write it down here. And then you just put ln and ln. Now, of course, what we will have next is whenever we have ln, the ln will switch with the limit. That's straightforward. So we get ln L equal, the limit will be out. And then we have the ln to the power of something. And this power will go down into the line. So it will be 3x ln of something. Of course, this is multiplication. Now, the next step is we do direct substitution. Maybe we need L'Hopital, maybe we don't need L'Hopital. If you do direct substitution, what you will get here is infinity. And what you will get inside is 1. So you will take ln of 1. So this will be infinity. This will be ln of 1, which is 0. So we have to multiply 0 by infinity. And that's really bad because if you remember, we don't multiply 0 by infinity. This again indeterminate form. So we need to take one of them to be in the denominator in order to use L'Hopital. I'm not sure which one is the easiest one, but usually I keep the ln where it is. So I will take this one to be in the denominator. So what I will do, I will keep the ln in the top. In the bottom, I will write 1 over 3x. Remember, if we take 3x from the top and we put it in the bottom, we have to write 1 over something. Now, if you look at this, this is the numerator, and this is a whole is the denominator. So now we can use L'Hopital, but let me check. If we substitute infinity, this will be 1 over infinity, so this will be 0. And this will be also ln of 1, which is 0. So perfectly fine to use L'Hopital. And we'll try to use L'Hopital here. H, L'Hopital. Keep the limit. Now take the derivative of the denominator. That's easy. Negative 1 over 3x times the derivative of 3x, which is 3. Sorry, this is x squared. Now derivative of ln is the same. 1 minus 1 over 2x times the derivative of the inside, which is negative 1 over 2x squared and then times 2. Ooh, it's too much to be done here, too much work, so we have to be a little bit careful with simplifying this one. So this is limit as x goes to infinity. Now, first of all, this will stay as it is. Second of all, the minus and the 3 will stay down. And 3 square x square will go up into 9x square minus negative and 2. This will be just a 2 in the top. And then 2x square will go into the bottom, which is 4x square. Simple cancellation. X square with x square. 2 and the 3, so this is 2 and this is 3, so the final one will be this one. It will be 3 in the top over 1 minus over 2x with a negative, so the final answer will be negative 3 over 2. And this is just ln L. If you want to get L alone, take E for both sides, so the answer will be negative 3 over 2. That's how we solve this question. This is a little bit of good question. It takes little of work, and we managed to solve it here. The next question is a very important question. Very important for us during this semester, during this chapter and the next chapters. So let me just write here important so that you don't forget it. How to do it, and the most important is the result of this one. Now here I want you to find the limit as x goes to infinity r to the power of x. Okay. Now, why this is important? Because we want to write the general rule for this one. So what I will do, I will directly use the same idea. I have something in the power, and that something goes to infinity, so I'm a little bit not sure what to do with it. So what we will do is we'll write L equal this limit. I will write len for both sides, and just let me take it inside the limits all at once. So what we have next is len L equal limit as x goes to infinity x len r. Okay. Now, what will be the answer? Of course, r is a constant. Now you have to ask yourself, r is a constant, so if this is 7 times x, and x goes to infinity, so I'm multiplying 7 by infinity, the answer should be infinity. Now, if this is 1 over 2, then we have infinity over 2, again infinity. If this is whatever number, the answer is infinity, except one case. Okay. In that case, when this is negative, then the answer will be minus infinity. So here we have to differentiate between several scenarios. Scenario number 1. Okay. Is that len r is positive, and we continue solving. Now let's say it's positive, then the limit will be some number which is positive times infinity, so the answer will be infinity, and then L will be e power infinity, and the answer is infinity. Okay. Now if L is less than 0, len r is less than 0, then the answer is negative infinity, and L will be e to the power of negative infinity, and this is 0. Of course, if len is exactly 0, this is a different story. We will leave it whenever we face it. It's indeterminate form. We'll have 0 times infinity. We cannot really say anything. So now the only question is, when do we have the len greater than 0? And this is the same as saying r is greater than 1. And this is, I'm saying here, is r is less than 1. Now, what's the importance of this question? And I will write it here in big box. And you need to know this box because you will use it throughout this semester. The box says that the limit as x goes to infinity. If we have a number to the power of infinity, the answer is, at least in this case, we have two scenarios. Either it's infinity if r is greater than 1, or you would just stop and say the number is 0 if r is less than 1. Of course, it should be greater than 0. Now, if r is 1, that's a different story. We'll not now discuss it, but for what we need now is either the answer something to the power infinity, either 0 or infinity, depends on the number r. So if I ask you how much 3 power infinity, you will say 3. But if I ask you how much half power infinity, you will say the answer should be 0, and so on. So just keep this one as a very important example here. And now what we will do next is I will use it to solve this equation. Solving this equation with L'Hopital is very, very hard, so I will leave it as an exercise for you. Use L'Hopital to solve it. Please let me know in the comments if you succeed using L'Hopital, taking derivative of the numerator, derivative of the denominator, numerator, denominator. Let me know if you succeed to solve this equation or not. Now, the way I will do it, because I will not use L'Hopital, is as follows. I will try to use the same idea we have seen in Calculus 1. Now, in Calculus 1, maybe you see many ideas. Usually, we take the highest power of x in the numerator and the highest power of x in the denominator, or the dominant function, as a common factor. Now, I will ask you, what is the common function, or the dominant function? Here, I have 2 power x and I have just 9. So 2 power x will go as common factor. This is 2 power x. Now the remaining is 9 over 2x minus 1. Sorry, plus 1. Same thing here, I will take 3 power x. This will be 7 over 3x minus 1. And now this is 2 over 3 power x, 9 over 2x plus 1, 7 over 3x minus 1. And now what you need to do, substitute infinity. If you substitute infinity, this will be infinity, this will be infinity. So you get 9 over infinity, which is 0, plus 1. 7 over infinity, which is 0, minus 1. How much is this one? Something to the power of infinity. How do we know how much it is? We have to look at this number here. And we compare it with 1. Is it greater than 1 or less than 1? In this case, this is less than 1. So we are done, because this will be 0 up here. And the final answer will be just 0. Two more questions. I will go through their ideas and we can see and we can finalize this section. So question 11 will be in the next video. Thank you.